Welcome cloud and security enthusiasts. Today we're diving into a detailed walkthrough of an Azure Zero Trust security architecture. Not only will I explain how this architecture enforces a Zero Trust model, but I'll also show you how the Terraform code is used to build it. Now, this design is perfect for government portals or enterprise systems that demand compliance with frameworks like NIST 853 and ISO 27701. So we're going to break down step by step, linking each component in the diagram to its corresponding Terraform code and explaining its role in the infrastructure. By the end, you'll have an understanding of this setup and how it secures workflows efficiently. Every Azure deployment starts with a resource group, RG, which acts as a container for all your resources. So let's take a look at the Terraform code. So here we have it, and the location variable determines where the resources are geographically deployed. For government portals, selecting the correct region is critical to comply with data residency regulations, like keeping US data within the country. Here's the backbone of our architecture, the hub and spoke network model. So the hub VNet is the central network that houses shared resources like firewalls and VPN gateways, and the spoke VNet isolates workloads such as an application tier while maintaining connectivity to the hub. Let's take a look at the code. So we see that code here, and the separation enhances security and scalability, aligning with the Zero Trust principle of segmenting resources. Next, we have network security groups, NSGs, which filter traffic at the subnet or NIC level. And so NSGs they basically enforce inbound and outbound security rules, such as restricting ports and protocols. So let's take a look at the code. So we see that NSG here. For a government portal, NSGs prevent unauthorized access, ensuring only specific IP ranges or ports like HTTPS are allowed. So to protect an entire network, we use Azure Firewall with a centralized firewall policy, and the firewall monitors and filters traffic, applying Zero Trust rules to block unapproved traffic. Let's take a look at the code. So here we see that resource. And for a government system, this ensures compliance with NIST AC3 by tightly controlling access between network segmentations. Next, we have our virtual machines, VMs, deployed in the spoke network. These are connected to a Key Vault, KV, which securely stores sensitive credentials like admin passwords. So let's take a look at the code. So here we see that virtual machine, and Key Vault integration ensures that no hard-coded credentials are exposed by aligning with ISO 27701, specifically Annex A94 for secure access control. Instead of exposing VMs to the internet, we use an Azure Bastion host to provide secure RDP or SSH access. So let's take a look at that code. So we see that here, and this aligns with the Zero Trust principle of least privilege access and eliminates the need for public IPs on VMs. To protect against distributed denial of service attacks, Azure DDoS protection is enabled on the spoke network. We see that here, and this ensures uninterrupted service even under attack, and this meets the CMMC level 3 requirements for availability. This Azure Zero Trust architecture combines segmentation, robust access control, and encrypted communication to protect workloads. With Terraform, this setup is automated, consistent, and scalable. For a government portal, this ensures compliance with NIST 853, ISO 27701, and CMMC, making it secure and efficient for public-facing services. Thanks for watching. If you found this helpful, like the video, subscribe, and drop any questions down below. See you in the next one.